It happened so fast, it's hard to remember exactly what happened. I was up out of my seat in a flash. Welcome to Lancaster Hi-Fi. I'm Stephen Lancaster, and I've got a problem. I had a problem last night that we need to fix. Sitting over there, I had just listened to side one of this album. And so, everything was on over here, but idle. I sort of looked up because I hear a hum that's getting louder. I look up at the amp here, and this tube is glowing bright orange and getting brighter. So I run over here and turn it off. I gotta admit, as a YouTuber, I did think for like a fraction of a second, get a picture of it first, get it on video. But no, I mean, if you see something like that happen, you gotta turn off the amp immediately. You're either going to, if the tube's not already destroyed, it's gonna get destroyed. And or you're gonna cook the output transformer. And I'm just hoping that if anything's wrong with either of those, that it's the tube and not the output transformer. Although these tubes, if I wanted to replace these tubes with, with Sylvania Fat Boys, it might cost as much to get one tube as it would to get a new output transformer. I don't know. I mean, even if I could find a replacement output transformer without buying a new amp. So I got to do two things. One, I got to take this one out and put another amp up there so I can listen to some music while I work. And of course, number two is I got to figure out what the hell happened. There is, I'd say, the most likely thing to have happened is that something went awry with the bias supply. The weird thing is, though, that it was just the one tube. That's so, if for example the bias supply just failed and went to 0 volts, then all 4 tubes would start glowing. But it was just the one. Maybe, I don't know, I'm going to have to look at the schematic to see like what could have failed, for example, to make the bias voltage at that tube 0. Because if the bias voltage for that tube went to 0, that could do it. But I don't know. Maybe a resistor failed. Here's the other weird thing is that this has small value cathode resistors, which I thought, part of the idea of why I put small value cathode resistors into fixed bias amps is so that if something like that happens, that little resistor will pop and shut down the current. That didn't happen. I'm trying to remember, I think that the little cathode resistors in there are the originals. They may be too robust. That might be a design flaw. Those might need to be replaced with lower power rating resistors that'll pop when something like that happens before the friggin' tube turns bright orange. I've never seen red plating like that. I've only seen red plating a few times, but I've never seen anything like that. It was like giving off light. It was, oh, wow. I mean, I don't know what would have happened in a few seconds if I hadn't gotten to it. Maybe that resistor that I'm thinking of, maybe that cathode resistor would have popped and shut it down. But if it hadn't, I don't know what might have happened. I mean, anyway, so I got to get to work here. I'm putting the Beaver Valley in, part because I haven't listened to it in quite a while, and other part because it has modern speaker jacks, modern style speaker jacks, so I can try out the cables that Chris lent me. But first I'm gonna try it with the old wires, speaker wires. Okay, just gotta, Things are in different places, of course. Giving myself a little more slack in the speaker cable. Alrighty, there we go. Don't like the sound of that. This thing should be dead quiet. And the right channel is, I'm going to try different tubes and different small tubes. I've got a pair of 6 DJ8s here. I think these are run-of-the-mill PSVANE. I'll just pull the one from the left channel, at least first. I suppose I could switch them first, see if that... Let me try switching them first. And sometimes things can change just by plugging and unplugging. Well, that's interesting, it didn't switch channels, so... So that means it's not those tubes. Like the other tubes. So I can try switching the output tubes. But those are like brand new Horizon tubes. It doesn't seem likely that that's the problem. Suspect something else. Don't know. I mean, I don't suspect anything else in particular. But, ouch. Those are hot. Alright, let's try this again. I predict that's not going to have any effect. It's not fixed, it's not all better, it's making ridiculous sounds. None of that's having any effect. Alright, well I guess this amp needs some attention too. Damn it. I guess they call this an embarrassment of riches. The one awesome tube amp totally flamed out. The second awesome tube amp got some kind of static issue, so I gotta go with a third awesome tube amp. Oh well, a Dynaco ST70. The switch is all the way on the back. It's so hard to reach. Okay, there we go. And it's also just so sad that I haven't yet replaced the input jacks, so my nice Riga Connect won't fit there. So I gotta use this old crap cable. Alright, time to get to that amp. So I've been trying to figure out what's wrong, and I have come up short. That is, usually what would cause this kind of red plating, or that kind of red plating, would be something wrong with the bias supply. And I can't find anything like a burned up resistor or capacitor or anything that would cause that. I'm going to do two things then. Well, what I did do, in case the problem was a bad connection to pin number 5, which is the grid pin here, if it lost connection there, suddenly the voltage would be 0 and you'd get red plating. So that could be the issue. So I went in with the sharp tweezers and I tried to sort of bend the metal a bit to make that fit tighter. What I'm going to do is two things. One, I'm going to check the bias supply at pin 5 up here. That's the one that was red plating. I'm going to check the bias supply there to make sure I'm getting the whatever voltage, the negative voltage at that point. I mean, I've checked continuity from here to the pin, and it seems fine. But I'll go ahead and check, turn it on without any tubes in there. The bias supply has its own winding on the transformer and its own rectifier, which is solid state. Actually, this has solid state rectification all around, so never mind. So I'll check the bias supply at the pin, and I suspect that'll be fine. But what I'm going to actually do as a potential remedial measure is replace the 8 ohm and 12 ohm resistors that are pretty beefy, too beefy to fail, and I'm going to replace those with half-watt 10 ohm resistors in each place. By changing those resistors, that will essentially make those resistors into fuses that will fail if something like that happens again. And if it happened once, who's to say it won't happen again? Now, you can say, well, golly, you're putting in parts that are meant to fail. Yeah, I'm putting in like parts that cost less than 10 cents to keep a $100-something tube from failing, to keep a $100-something output transformer from failing. Yeah, definitely, that's what I'm doing. All right, here goes. Oof, careful. Even without any tubes in, it does have solid state rectification, so there will be high voltage in here, so I gotta use one hand, use the usual safety rules. Okay, so there's our 500 volts. Yikes. Minus 32.5. minus 32 something. Okay, so I'm getting negative voltage at all of the places, at all of the pin 5s, as I should. And so that's consistent with me not being able to find anything that was terribly wrong in terms of getting that voltage to those points. So that leaves us with, you know, a bad pin connection. I mean, the voltages are checking out. I'm going to turn this off because that's a pretty high voltage. Yeah, got to be careful here. That maybe wasn't wise. So, for example, that's a 450 volt rated capacitor, which ordinarily wouldn't be a problem because there'd be things drawing current and bringing the voltage down. But without any current being drawn, high voltage was up at 520 and there wasn't any dropping across this big resistor here. That was sitting up at 520 as well. That is over the rating for that capacitor. Well, I hope I didn't screw anything up too badly. Let's give it a minute. We'll get out some 10 ohm resistors. So I need, I think, 6 of these, right? 3 per channel. Replacing each of the 8 ohm resistors here and here, and there, and there. And each of the 12 ohm resistors there, and there. So after clipping those off, I will go in and try to get off the cut ends just to keep things tidy. I'm also going to touch up some of these solder joints in the path of the bias voltage supply, just in case there was an issue of a cracked joint that's not showing up now. I think the only thing to do now is to put the back on, put the tubes back in, and set the bias. See if anything like what happens before happens again.
Let me stay here, let me please. She's still wearing her father's feather jacket.
So we especially want to keep our eye on this one. I've just turned it on. I'm supposed to adjust the balance first. Alright, now we go back to channel A. I put one of the probes in the same set of holes and the other one on the 8 ohm connection for the speaker outputs in channel A. Now I turn this up to 1.4 volts.
Ever since you were a kid, you could cry on command.
And similarly for the right channel.
It's a scam. Always said that she didn't.
And then we do everything again. Balance and bias. So that's telling me that the voltage on the cathode of this one is going down relative to the voltage on the cathode of this one, which would mean this one is not wanting to draw a current and it's drawing less and less. Jeez. Yeah, I can't adjust it any further. Oof. And now this tube is starting to red plate. I'm pretty sure the one that was red plating before was this one. I kept track of the tubes, which sockets they were in when I put them away and put them back in. I think what we were seeing then is not that this one was drawing less and less current and the voltage was dropping, but that the voltage on this one was going up and up and it was drawing more and more current, obviously, because it then started to red plate. Alright, I've been looking online to try to find replacements for these sockets, and I'm just not really finding anything that's a good replacement. The pin grippers in these sockets look to be essentially things sort of shaped like that, and just prongs. But my standard sorts of tools that I would think to use to get in there, like these, just don't get in there very well. So, taking the smallest slot screwdriver head from my set here, and I'm going in and just prying them from each side. And I'm hoping that'll work satisfactorily. And I guess we'll see. I've tightened up all the pin sockets, so we're going to try this again. Let's see, I've turned the voltages both down to the minimum, counterclockwise all the way. And the balance is to, well, I've left this balance where it was, but this one I've tried to put back into the middle. And I'm going to try this again. Of course, everything went smoothly the first time around for a while until it didn't. Rather dramatically didn't. So let's just try this again. Now the first thing we're going to do is try to... Oh, I forgot to turn the back on. Got two power switches on this one with the power input module on the back, so we turn that on first and then turn it on the front here. The light comes on, and of course we're going to be watching these tubes closely for any red plating, but fingers crossed. I've gone through and tightened up each pin socket considerably. I did measure the pin diameters, and the pin diameters were on the thin side, so perhaps that had a little bit to do with things going so terribly wrong. Alright, so I'll let it warm up for a bit. So let's figure how to set the bias here. That is, in the original schematic, we see there are 6 ohm resistors here, and then where it joins, we've got 12 ohms. Okay, and 12 ohms is connected to ground. Now, the way to look at this is that, well, we've got 1.5 volts between here and ground. The way to think of it is that we've got both of these going through, so effectively we've got 6 ohms and 6 ohms in parallel. 6 ohms and 6 ohms in parallel is the equivalent of 3 ohms. So 3 ohms plus 12 ohms, 15 ohms. So 1.5 volts with 15 ohms is 100 milliamps. Now, I've replaced these resistors. I didn't like just how beefy these were. I wanted something wimpier so that it would blow more easily. I've put 10 ohms here, 10 ohms here, and 10 ohms here. So 10 and 10 in parallel is 5, plus 10 is 15. So it's the same 15 ohms effectively. So I will be needing to, again, adjust to have 1.5 volts. So nothing should have changed about that adjustment. Awesome. Now, I've been letting this stabilize, or warm up anyway, for a while now. I couldn't help but adjust it to nearly 0, but it's come back towards the direction that I adjusted it from. And it seems to be still moving in that direction, but it has been a good while now, and I think I should proceed with the adjustment, and then we'll just see after that. So I'm going to turn this adjustment back up to where that'll be 0. Oop, too far. Okay, that's good for starting. Let's check the other channel. Now, one of the things that I need to be especially careful with is as I reach over and so on, that I don't knock those power tubes. Because we know that the fit in those sockets is an issue. Or at least we think that's the issue. So I got to be real careful not to bump those and, stretch those sockets back out. Anyway, move the probes over to the other side. Do I believe that? Well, I mean, it should be right, actually, because I haven't done anything with the adjustment or the tubes. Let's just see. Does it respond? Yes, it responds. So let's call that good for now and proceed with the voltage adjustment. Now for that, and you can't see what I'm doing, of course, is I just need to hook this to a particular one of these speaker terminals. And I can tell which one by just how much room there is there to stick a probe. Try to tighten this down so that it sits in there snugly. Now all we got to do is now put this just in one of the holes that we were using before. Shouldn't matter which. Okay, so you can see it's down at 390 millivolts, and we want to put it up to 1.5 volts. So we're using this voltage adjustment pot right here. Now remember, we shouldn't be surprised that it was so low because we'd turned it down all the way on purpose. Oops, that's getting too much. Dial back there a bit. I can hear a little tink tink, which does, I must admit, make me just a bit nervous. But so long as everything behaves, it just means that the tubes are a bit hotter. Alright, quickly go ahead and switch to the other channel. Uh-oh, too much. Okay, now we need to go back to checking the balance on channel A, balance on channel B, bias again once we get done with that. Cut off a bit because the memory filled up. Anyway, we're just getting this channel's balance situated pretty much about where it needs to be. Probably shouldn't even have touched it. Okay. Check the other balance real quick, and then we'll check the bias again. Okay, looking good so far. I think that's about where I left it before. Turn it up just a smidge. Okay, let's try the other channel. Turn it down just a smidge. Very nice. Now the instructions say to let it run for about 5 more hours and then check it again. For now, I'm going to put these covers back on. So knock wood, it would appear that I have fixed it by squeezing in those pin sockets. And I did squeeze them in quite a bit. I wanted them to be good and tight when I put the tubes in. Obviously, this is something I'm going to want to monitor. I don't really want to leave this unattended. It does have fail-safes. I mean, it's got fuses on each channel, so those should, those should presumably blow when current gets out of control. It's got the half-watt resistors in the cathode circuit. Those should presumably blow when the thing gets out of control. But what we've seen already is that it can get out of control and none of that fails. So makes me wonder just how far out of control it has to get before things go, before the things that are supposed to fail do fail. In any case, this is quite good. For now, at least. Everything is just as it should be. But everything was just as it should be for before. It just all of a sudden wasn't as it should be. I do think, though, with the degree to which I've tightened up those pin sockets, I think, knock wood and fingers crossed, that it'll be fine. As long as I don't do something to stretch them back out. But that is something that we do need to be aware of and, guard against. If I put different tubes in there and the pins are slightly larger than these, then, I got to be careful with that. I mean, if I put in different tubes with larger pins, that'd be fine. But if then I take those out and put these back in, then it might not be fine. Well, I've had it running for 8 hours, and everything seems to be fine. No red plating. Voltages all check out. So that seems to have been the problem. The pins, or the sockets. The pin sockets. That's a thing. Well, hope you learned something from this video. I sure did. And if you learned something, if you enjoyed the video, give it a thumbs up, subscribe to the channel. Looking forward to hooking this thing back up and listening to it. Cheers.